First formula we discussed was admiralty coefficient, which was delta 2 by 3 v cube over power. So we have to remember that in case of admiralty coefficient formula, there is no mention of any fuel consumption. It is independent of fuel consumption. So any numerical where SFOC is not constant, we will not use the fuel coefficient formula, but we are free to use admiralty coefficient if applicable. Fuel coefficient formula, which is again on the same lines, except that fuel coefficient is equal to delta 2 by 3 into V cube divided by daily consumption. So that is the only difference. In the admiralty coefficient, we have power in the denominator, whereas in fuel coefficient we have daily consumption in the denominator. Similarly, we also developed a formula for the voyage consumption, and we saw that the voyage consumption 1 over voyage consumption 2 is equal to delta 1 delta 2 raised to power 2 by 3, but here instead of cube we have square of v1 and v2, so v1 by v2 square, but multiplied by voyage distance 1 divided by voyage distance 2. So these are the only formulas so far we have discussed. So we of course we did a couple of numericals also. So we'll now move on to some more numericals, and let me open the PPT and then we'll continue with the numericals, which, as I said, will be slightly, you may have to think which formula to use, how to proceed, but you will be able to do it. Okay, so let us start with the simple one. The next one will be slightly more difficult. As I said, we'll be gradually moving towards questions where you will be requiring some kind of thinking. Okay, this one is more or less on the similar lines. So this is just a practice one. Let us do it. A ship travels 900 nautical miles at a speed of 12.5 knots and burns 150 tons of fuel over the voyage. Estimate the distance the ship could travel at a speed of 13.5 knots on 250 tons of fuel. So how much is the distance? How much distance we will be able to travel? That is what we have to calculate.
Sir, 1286 nautical miles.
1286, correct. 1286 is right. So I will give 1 or 2 minutes more for those who are still calculating. But I would appreciate that all of you do it simultaneously so that we can go on other questions. As I have told you, in case you find any difficulty, you can ask me.
Sir, can you please repeat the answer?
Answer is same, but you said 1286.
Yes, sir.
Yes, sir, 1286, sir.
1286 you should get. Nearly same you should get. Maybe decimal point here and there. So everyone got it correctly? All right. So now we move on to another one. Now this question has come a couple of times in your past papers. So just first try solve yourself, although it is also not difficult, but since this is a question which is coming with some slight modifications of values here and there. So looks like it is popular with the paper setters. The daily fuel consumption of a ship at 15 knots is 40 tons. 1100 nautical miles from the port, it is found that the bunkers are reduced to 115 tons. If the ship reaches port with 20 tons of fuel on board, calculate the reduced speed and the time taken in hours to complete the voyage.
सर रिड्यूस स्पीड आ रहा 13.22 नॉट्स और टाइम आ रहा 83 आवर्स 20 मिनट्स.
Okay, just a second, please. Reduced speed, how much you got?
13. Yes, sir.
13.2. Okay.
Or
And
83,
hours?
20 minutes.
83 to 20 minutes. Okay, good, very good. Who has done it? What is your name?
Mukesh.
Mukesh. Okay, good, Mukesh. Very nice.
Thank you.
Okay, so what about others? Because I want others also. Everyone in this group must be able to solve it.
सर कैसे करेंगे सॉल्व इसे?
Okay, I'll give you a hint so that you can. First of all, let me just explain what it is trying to say. मैं थोड़ा अपना लैपटॉप उल्टा कर रहा हूँ, just turning it around. I'll try to write here only on this screen. So the condition is like this. The vessel is proceeding like this. This is the port and we are here. Before this point, now if I say distance to go is 1100 nautical miles. This is the scenario. That means before this vessel was proceeding at the speed of 50 knots. So 15 knots is the condition before this happened. It is found that the bunkers are reduced to 115 tons. So at this point, I have ROB is equal to 150 tons. Correct? Now I know I have still to go 1100 and I have unpumpable of 20 tons. So ROB on board on arrival should be 20 because that is unusable. I can't use it. Therefore, practically for this 1100 nautical miles, I have 115 minus 20. Only that much of fuel I have usable oil. So if this is my V1, I have to reduce my speed V2 in such a fashion that I consume only 115 minus 20, 95 tons of fuel during this passage. And therefore, I can use the voyage consumption formula. This is one set before this. Second set is here. V1 is 15, V2 is here. What will be the consumption? Now, if I can use voyage consumption formula directly. VC1 by VC, sorry. This. If you see here. So before this, if I use the formula, where should I write? Can I write here? Yeah, VC1 by VC2 is equal to delta 1 by delta 2, 2 by 3, V1 by V2 square into voyage distance 1 over voyage distance 2. Now numerator is all parameters for one set. Voyage consumption 1, displacement 1, V1, voyage distance 1. So let us consider a voyage before this of 1 day. If I consider a 1 day voyage, my voyage consumption will be 40 tons. So in numerator in this formula will be 40. Now let delta 1, delta 2 same. There is no change in displacement. We have not loaded cargo nor discharged cargo. And V1 is 15 knots. V2 I want to calculate. Voyage distance 1 in this case, first case for 1 day voyage will be 15 into 24. That is the 1 day voyage. So voyage distance 1. Voyage distance 2 is 1100. That's all. So you will get the speed V2, the reduced speed at which you go to reach with 20 tons on board. And once you know this speed, you can calculate the time because you have the distance and the speed. All right, is it understood? Okay, now you please solve it. And let us see if you get the same answer or the answer.
This is 13.21, 83.21.
Time you should be getting, I think, around 82, 81 point, 83, yeah, 83.2
Okay.
and 13.2.
83.2.
13.2 will be the speed. Correct. Absolutely correct. So everyone got it, or there are some more students who are still solving it?
सर वो लेके जाओगे स्लाइड पे आंसर वाली स्लाइड पे एक मिनट
No, no, you asked me. I am not giving you for copying the answer. I want you to be doing it. And if you find difficulty, you ask me.
मेरा वैल्यू कुछ और आ रहा है सो 7 पॉइंट पता नहीं कुछ मेरा कैलकुलेशन मिस्टेक है इसलिए पूछ रहा हूँ
So calculation, yeah. So then please check your calculation. Formula is on your screen, as you can see. Delta 1, delta 2 cancels out. There is no change in displacement. So it is 40 by 95 on the left hand side equal to V1 is 15. V2 we have to calculate square of this. Y distance 1 is 15 into 24. Y distance 2 is 1100. This is a straightforward equation. Correct?
ठीक है सर राइट अभी मैंने वो 24 लिख किया
So please
Okay,
do it. Don't go for just copying the answers, because in exam you may find this varied. It may be 15 की जगह 12 दे देंगे वो. Then what you will do? So procedure should be known to you. You should be able to solve it correctly. That is the whole idea. If you have difficulty in understanding the question, I am here to tell you. So please check again. Maybe some small mistake, because even my slide will not give you that part. Anybody who has not been able to do, or anybody is still struggling with the
the time is 3 days 11 hours right
time is
3 days 11 hours right?
have you read the question? Please read it again. If the ship reaches port with 20 tons of fuel on board, calculate the reduced speed and the time taken in hours. Your answer should be in hours. So many hours and so many minutes probably. Or if you want to write decimal, then so in hours only they want, not in days. So let us calculate in hours. If they did not mention, and if they had not mentioned anything, yes, then it would be okay. All right, should we move forward? Everybody has done it. Anybody who is still doing it, let me just ask this way. Both ways, no answer. All right, so okay, let us do this next one. A ship uses 23 tons of fuel per day at 40 knots. Calculate the speed if the consumption per day is increased by 15%, reduced by 12%, reduced to 18 tons. So we have daily consumption given as 23 tons per day at so and so speed. That is given to us. We have to calculate if we increase the speed by 15%, consumption by 15%, then what will be the speed? If we reduce the fuel consumption by 12%, what will be the speed? And if my consumption is 18 tons, what will be the speed?
Like 14.12.
Let me check. Have you calculated all three?
Only one.
So V1, how much? 14.12. 14.12. Second one?
Sir, 8 yeah, मैंने 8.
अच्छा तीनों कर लो. Then I will tally.
हाँ, so पहले का आ रहा 14.66 नॉट्स, दूसरा 13.41 और तीसरा 12.90.
ठीक है, it's matching. That's why I've written on board on the screen the answers. So 14.66 या 67 is okay. 13.42 for the second one, and third one 12.9. This also is a question whereby there are similar questions with some data different here and there. So you must try those also, because we can only do in class different types of questions, but we can't do each and every question. There are hundreds and hundreds of questions available. Also from the past papers, so most of it are from your past papers. Hello. हाँ. हाँ बोलो सही. हाँ मैं थोड़ा गया. हाँ थोड़ा. अभी कहाँ गुंजाइश है हमारे हमारे उसमें अभी गुंजाइश थोड़ा लेने की. मेरे ख्याल से तो काफी. अच्छा चलो ठीक है. हाँ. कि अभी तो हाई है. एसआरएफ कितना है अभी तो 10 समथिंग. हाँ. हाँ है अभी. अच्छा चलो ठीक. हाँ. अच्छा. अच्छा ठीक है मैं देखता हूँ. हाँ बैंक की मैं देख रहा हूँ. ठीक है. तो फोर्ज में भी थोड़ा मूवमेंट. हाँ तो फोर्ज में भी थोड़ा मूवमेंट है. हाँ ठीक है. थैंक यू. All right, so everybody got it. Can we move to the next one? Okay, let me put it this way. Anybody has not been able to do it, please let me know. Okay, so we'll go forward. Let us see the next one. The normal speed of a ship is 14 knots and the fuel consumption per hour is given by 0.12 plus 0.001 V cube ton with V in knots. Calculate the total fuel consumption over a voyage of 1700 nautical miles, the speed at which the vessel must travel to save 10 tons of fuel per day. First read it carefully, see what is given, what we can how we can solve it, and then once you have gone through it, then we will discuss if you require. Otherwise, let us solve it.
सर ए पार्ट का आंसर है 347.2 और
177
दूसरे
and
पार्ट का
13.7
12.9.
Okay, first part is the total fuel consumed. फर्स्ट पार्ट का कितना आया
347.7 एंड दूसरे का 12.94 सर स्पीड
स्पीड
So speed 13.79. 13.79.
13.25 you should get.
सर फर्स्ट कहाँ आ रहा है 347.77 टन और दूसरा आ रहा है 13.25.
First part is correct. 347.7 is correct. Second part, just check again. 13.25 you should get.
सर सेकंड का 13.25 ही आ रहा है.
हाँ फिर ठीक है. नहीं किसी का कईयों का नहीं आया ना, इसलिए कह रहा हूँ.
सर स्पीड रिपीट करना 13.28 राइट.
Correct. 13.25. So 13.2 is okay.
और भी आते हैं क्या न्यूमेरिकल या इसी टाइप के आते हैं या और भी है अभी?
Numericals और भी हैं, different types के. अभी I will be there are numericals on fuel consumption, there are numericals on power calculation, there is numericals on propeller pitch. So there are some more different types. So we'll be covering one by one.
तो इससे भी हार्ड है क्या सर? यही काफी हार्ड लग रहा है, फॉर्मूला याद नहीं रहे.
इससे भी हार्ड है. इसमें क्या हार्ड है बताओ मुझे, किसी को. अच्छा किसको समझ नहीं आया, लेट मी जस्ट. इसमें ये जो न्यूमेरिकल है इस टाइप के, ये एक ही नहीं है. देयर आर, इफ यू सी द पास्ट पेपर, दिस इज अमंग द पास्ट पेपर्स, but you will find a small variation. The equation may be different. So it is an equation which is given. You have to use this equation to solve it. If you solve it by some other means, it will not be correct, because this in this one the consumption is varying with the speed relationship is given. This is, we have to take it as C, for example. सबका आ गया या नहीं आया? Then I will explain those who have not been able to solve. काफी लोगों का तो आ गया मुझे लगता है. So let us see how to do it.
For part B,
हाँ जी.
answer for part B, speed.
स्पीड का आया है, आपका कितना आ रहा है?
So 13.28.
13.28 ठीक है. or 26. So you have to make two equations now. If C is, let us say C is the consumption, तो अगर पहली C is equal to, let us say equal to, ये तो given ही है 0.0 12 plus 0.001 V cube. This is given. अब हम लेते हैं कि अगर 14 नॉट्स है, फर्स्ट कंडीशन 14 नॉट्स है, सो V is V1. तो व्हाट इज द पर आवर कंजम्पशन? C1. Sorry, is equal to 0.12 plus 0.001 and within bracket will be 14. This will be first equation. Sorry, second equation. This is given anyway. And then if the speed is changed, this is per hour given with V knots. So if we have to calculate for a voyage of 1700 nautical miles, correct? So how you have done? This is, I mean, this is clear, na? C1 or the daily per hour consumption is so much. So we can calculate putting the value of V, which is given at 14 knots. So at 14 knots, we know what is per hour consumption. And if I want to, so fuel consumption over a voyage of 17, we can calculate because we know the speed is known to us and the daily per hour consumption is known to us. So we can calculate part A simply from using this equation where V is 14 knots. Correct. So part A has no problem at all. Part B, we want to move the vessel at a certain speed so that we have a saving of 10 tons per day. So if I want a saving of 10 tons per day, I can say 10 by 24 is the saving in per hour. So my new per hour consumption will be whatever I got here original. What was my original consumption here? How much you got? 1 point something? 1 point, let me check. What was the
0.864.
1 point and 2.86. 2.86 was the original, correct? So new consumption will be 2.86. This is per hour minus 10 by 24. This is a new consumption. When this is a new consumption, I again use it in this equation and I can calculate V. So this is the method of calculating this or solving this problem. We have to use the same equation. Is it clear or is it still, or anybody still has doubt? Part A is straightforward. Just put the value of speed 14 knots. You will get the consumption in per hour. Multiplied by 24 is your daily consumption. 1700 divided by 14 into daily consumption is the consumption for this voyage. First part. In second part, this per hour consumption reduced by 10 by 24 because we want to calculate the speed at which the vessel should move if my daily consumption is reduced by 10 tons. So daily consumption means per hour consumption must reduce by 10 by 24. So that is my new per hour consumption. Use the same equation, calculate the value of V, which I'm sure you got how much? 13.25 and 347.7 you got for the other one.
इसको जो आपने बताया था 24 आवर्स का वॉयस लेके सेकंड पार्ट को नहीं कर सकते वैसे?
24 आवर्स का वॉयज लेके
हाँ, जो पहले कर रहे थे न्यूमेरिकल उसके हिसाब से नहीं कर सकते? जैसे एक दिन का डिस्टेंस निकाल लेंगे 14 नॉट से और 1700 दूसरा डिस्टेंस है हमारे पास, उससे नहीं कर सकते? डेली कंजम्पशन भी है हमारे पास.
See now this particular numerical fuel consumption varies with this. जहाँ पे आपको ये relation आ जाता है ना, so that assumption does not hold good that the SFOC is constant. So only use the equation which has been given for the variation of fuel consumption, because this is not a linear equation. अगर वो directly proportional हो, why it is not? Because if you know from algebra, any constant plus a variable, है ना, it is not a linear equation. So that is why we must use this equation only. Don't use fuel coefficient relationship. वो जो relationship है वो उसमें हमारा first thing was assumption that the SFOC is constant. Correct? In that case that will be linear equation. Proportional, directly proportional. ठीक है ना? इसलिए otherwise probably answer may also come nearly same.
वॉइज कांस्टेंट फॉर्मूले से सर अगर 24 आवर्स वाइज वही वाला लेके नहीं फिर सही नहीं होएगा वो।
अभी तो मैं वही तो बता रहा हूँ आपको कि SFOC अगर कांस्टेंट है तब ही हम वो फ्यूल कोफिशिएंट का फॉर्मूला लगा सकते हैं। आपको मैंने यहाँ बताया था ना, ये देखिए इनिशियली हमने क्या किया था, ये रिलेशनशिप SFOC की ऐसे है, इसका मतलब है अगर मैं डबल वो कर दूं पावर तो कंजम्पशन डबल नहीं होती है। तो हमारा फ्यूल कोफिशिएंट में हमने तभी लगाया है ये फार्मूला कि हमने अज्यूम कर लिया कि ऐसा है। तो ये ओनली दोज केसेस वी कैन यूज वेयर आई एम अज्यूमिंग it is, if it is assumed that the specific fuel air consumption of an engine remains of engine power, it can be said that the fuel consumption per day is directly proportional to the power output of the engine. तो जहां पे SFOC कांस्टेंट है ये मैं लगा सकता हूं। क्यों? ये जो फार्मूला है फ्यूल कोफिशिएंट का, इसी से तो मेरा वॉइस कंजम्पशन का भी फार्मूला आया है ना, वॉइस कंजम्पशन 1, वॉइस कंजम्पशन 2, तभी तो मैं लगा रहा हूँ वन डे वॉइस लेके, कंसिडर ए वॉइस ऑफ वन डे, दिस इज ऑल फ्यूल कोफिशिएंट फार्मूला। सो दिस आई कैन ओनली यूज प्रोवाइडेड SFOC इज कांस्टेंट। लेकिन अब जो न्यूमेरिकल में दिया हुआ है फ्यूल कंजम्पशन का वेरिएशन दे रखा है, सो we must stick to the relationship for fuel consumption which is given. ऐसे एक आध और भी है क्वेश्चन, फॉर एग्जांपल लेट मी शो यू, ऑल्दो वी ये वाला देखिए, इसमें क्या है, शिप 800 नॉटिकल माइल, द फ्यूल कंजम्पशन पर आवर इज गिवन बाय दिस रिलेशनशिप 0.136 plus 0.001 V cube. So this type of relationship also you must use the expression for fuel consumption given, because it is not a it has got a constant plus then V cube, correct, variable cube. स्ट्रेट लाइन में क्या होता है कि आपका some constant into the second variable, correct? If it is x then something into y, then it is a straight linear relationship. That means it remains SFOC is constant. But in these cases, to avoid any confusion, use the relationship directly. Use what is given. Don't go for this fuel coefficient. But if it is not given this type of relationship, go for it. Although I will show you where it is mentioned SFOC is not constant, then also I cannot use. For example, there is another question you will find in your past papers. I will also show you. So those type of questions are the one where you must not use this relationship. I mean that fuel coefficient formula, because that is basically, it was mentioned by me in the beginning only. Assumption is that SFOC is constant. Okay. All right then. So we stop here. We will discuss further in the, I think afternoon also I have one class with you. So if any doubts, we will discuss that time. Okay. Thank you.
Okay, thank you.